So welcome to part 2. I decided to split this up because there's a lot of slides. You can't see, well, if I move my face, you can kind of see it. 69 slides. There's 140. So I decided to split it in half to make it easier for you to ingest it as you go along. So let's jump right back in. So when we format algorithms in the first case study, we find out that the average calculation in the program produced an integer result of 81. Actually, the sum of the grades in this example is 817, which when divided by 10 should yield 81.7. So remember that we were doing a program that calculated grades. It calculated the average of the grades that were entered into the program. Now, when you have a decimal point like this, it's called floating point. In programming, we don't call it decimal. I understand that in C# there is decimal, but for the most part we use doubles, floats, and integers. A float is a larger span of numbers in the decimal point, whereas I think a double is less. There's a specific reason behind, or I know the reason why, but there's a specific size parameter between doubles and floats. And the reason why that is because in C++, as well as in C, you'll find that we run into memory issues. And so we try to minimize the amount of memory values that we consume with our values. So if we generalize the class average problem, we'll consider the fact that we're developing a class average program that will process an arbitrary number of grades each time the program is run. Now, remember that in this program, we were only calculating 10 grades. Now, that's not conducive to a real-world example because in the real world, you might have a class with 20 students, you might have a class with 12. There might be 15 or 29. So we don't want to always code the amount of positions that an array will have. What we want to do is make it to where that we can allow the user to put in an arbitrary amount of numbers, and then we can calculate the average grade from that arbitrary number. So we can use what's called a sentinel value or a signal value or a dummy value or a flag value or an integer or an index or a counter it's just a way that we can determine when a loop should stop. Now, in higher level languages, what we have is we use like for each loops, and then we look at arrays and we say for each element that's in this array, what I want you to do is I want you to calculate the algorithm, and when there's no more elements in this array, then I want you to stop. In this case, I'm more than 100% sure that you're not going to have the ability to use for each, but you will have the ability to use a for loop, and I showed you how for loops work, and for the most part, they work the same way. What we're doing in a for loop, and if I bring that back up, I guess I didn't show you the for loop, but if I'm not mistaken with the syntax, and sometimes you can be mistaken, for var I equals 0. In this case, var, it could mean, I was typing in JavaScript earlier today, so there are no vars in C. So what we're going to have to do is define the index as an integer. So int I equals 0. Then so there's 3 different parameters in this for loop. The first one is we're going to define the index or the counter. And the I stands for what we basically needed to do. Now, what I'm going to do here is I'm going to erase this, and I'm pretty much going to show you how this for loop works. And I'm taking the time to show you this because I know for a fact that for loops are pretty much the loop of choice for most programmers, and there's a good reason why that is. Let me go ahead and look up the syntax for this. Excuse me. Right. That's not what I wanted. I know the syntax for the for loop. I need the syntax array. For the most part, we use for loops to iterate through arrays because arrays have more than one value. So in this case, what I will have is I'll have a string names. All right, cool. So I see what's going on here. Names, we'll say we'll have 3 names equals, and then we'll add the names to this array. So we'll have my name, Francis, Nathan, and then Samantha. Okay. So we have an array with names in them, and it looks like it doesn't like my identifier. String is undefined. How, why? What did I do wrong? Give me 1 parsec to look up what I did wrong. Please and thank you. Oops, that's not what I wanted to do. Thank you. Okay, so double balance. Still, what did I do wrong here? Can I not have a string array? That doesn't make any sense. Okay, so I guess I'm not going to make a string array because it doesn't like it, so we'll do int array. Are you? Oh, I know. str is string. Once again, I think str. The syntax is different between languages, so it just takes a little bit for you to get an idea of how you're doing or what you're doing. And it looks like string is not. That's weird. I could almost guarantee you that string is a data type. I just don't. I don't see the. Okay. Just show me the syntax, please. I guess it is str, but I don't know why it's doing that. Is it char? I don't like that, but I guess we'll do that then. Will it stop? And now it doesn't like these. Why? Oh, jeez. Alright, I got it. Are you gonna stop now? Oh, right. This is in the wrong, fine. Char. Is that good now? Oh, this is taking longer than I thought it would, unfortunately. Right, so it should be char, and I was right the first time. I don't understand why this is acting the way it is. Maybe it's because I didn't give it a value of type const char cannot be used to initialize the entity of type char, but this isn't const. Alright, so let's do const, alright? So what now? The type of const char cannot be used to initialize the type of const char. Okay, how about that? Oh, it liked that. Okay, so what if I do that? Okay, no. Fine. We have our array. We have our array with strings. Done. That was painful. Okay, so now what I want to do is I want to create my for loop because I want to print all the names. I'll get rid of that. Print all the names that are in my array. Names. And I created that array. I called it names myself. Don't get your mind too wrapped up about how or about why. Just know that's how you make an array. I could have made that int and put numbers in there. I could have done a whole plethora of things, but I'm using char for now to create my strings. So I want to print every name that's in this array. So I need to iterate through the array. So for int being the data type of the variable I, which is our index, and then I said I need 0 to be I, or I needs to be equal to 0. Now I'm going to say while I is less than names dot length. I'm assuming that length is a part of this yet. Array length. Once again, I've been writing in JavaScript, so please forgive me. Maybe it's this. Names. Wow. Okay. That's very interesting. I hope that works because I've never seen this syntax before. Normally it's dot length or something like that, but apparently not. Yep, okay, I guess it's size of. Okay, so size of is how we'll get the amount of elements that are in this array. So while I is less than the amount of things that are in this array or the amount of elements that's in that array, and then I plus plus, which is shorthand for add one to I, or increment I once, or increment I by 1. Alright, so now let's make our code. So we're going to say printf And then we're going to say names I. Now, what's going to happen? Well, what's essentially going to happen is this const char names is going to initialize with three positions. And then it's going to enter Francis, Nathan, and Samantha into all those positions. So names is going to have Francis, Nathan, and Samantha as strings in the 0th, the 1st, and the 2nd position. When the for loop runs, it's going to initialize the integer I to 0. While I is less than the amount of things or the amount of names or the amount of strings that is in the array names I want you to run. Which is the same as saying when there are no more, or when I is greater than the amount of elements that are in the array, stop running. Then after each iteration, I want you to increment I by 1. So what's going to happen? Well, I can show you actually in the debugger if I do this. If I can remember how to... That's funny. I'm just forgetting everything. Give me 1 second. Great. Visual Studio. Yeah, that's all I really want to do. That's... Interesting. So normally if you click to the side here, you can put a breakpoint. Oh, there it is. Okay. Whew. So if you click to the side here, you can create a breakpoint. And what a breakpoint is it stops when you run your code, it stops your code at that specific point so that you can see what's happening. I'm going to put 2 breakpoints here. Normally it's used for debugging. And that's what we're going to do. We're going to debug this to see what's actually happening. All right, so let's run this. All right. There we go. We're inside the code. Notice there's an arrow here. That means that the code stopped. If I want to go to the next step in the code or step through that, I have to click next statement, or I can step into the next function, I can step over the next function, or I can step out of the next function. Don't worry about all of this. Just know that this is going to get us to the next statement. So right now we're looking at for, okay? And I just went to the next function, but what for is actually doing, I is 0 right now, so I'm scrolling over the I. You can see that it's 0. And then names is going to give me the array. So while I is 0, I can use I as my index in my array. Now, what does that do? Well, what's in the 0th position in this array? If you count 0, 1, 2, Francis is in the 0th position. So names index 0 literally means give me the element in the 0th position. Whatever this number is here, it's telling the program to give me whatever element is at that location. So everything in computer science starts at 0. So Francis is at the 0th location. This is going to print my name. It's going to iterate. It's then going to say, okay, what's in the 1st position? Nathan. It's going to print Nathan's name, iterate, and then it's going to see what's in the 2nd position. So let's watch it as it happens. Here's the program. There's nothing printed right now. So let's go ahead and go to the next. Next, please. Can we continue? Access violation reading location. What did I do wrong? Ah, there it is. Francis, Nathan, Samantha. So it didn't. I wasn't able to iterate it because I didn't iterate correctly here. But that's not the truth. But let's stop that. But as you saw, I printed all the names on the same line. Now, if I was a smart person, I would have put breakpoints in there. And what that means is new line. And if I ran this without the breakpoints, or actually, I'll run it with the breakpoints. Let's try that again. So right now, there's nothing in the console. I hit the next. If it decides to step over. Okay, there we go. So, I'm having a grand old time, aren't I? There we go. So there's nothing there. It didn't print the name yet. There it goes. There's still hasn't printed the name yet. There, it should have printed Francis. Well, it should have. Let's continue and get it to stop. Change the PDP search paths. I don't know why that's doing that. Because I don't really care about this. But let's go ahead and exit this. And let's just run it. Alright, so here we go. Edit conditions. I don't know what I did. Why is it doing this? There are no modules. And it just worked too, so now it's gonna decide to blow up in my face while I'm recording. That's wonderful. Alright. Interesting. I'm gonna try to run it one more time, and if it gives me grief, I'm just gonna close this project and open a new one. There we go. Some of it worked. Why? That's weird. I've never seen that error before. Alright, run that then. Oh, maybe it didn't like the new line. And this PBDB is a very interesting error because it's telling me something crashed, but nothing crashed. Access violation. Oh, it's telling me I'm not allowed to read certain. Okay, so this is a funny error. Okay, now I know what this error is. What this error is telling me is I can't read certain memory locations in my memory because it's reserved by the OS. I get it. Remember that C actually modifies the OS specifically, so you want to be careful when you modify C. But c'est la vie. Okay, let's put that away. Let's stop. And let's go ahead and let's keep going. So, we spoke about sentinels. The sentinel in that for loop was the I. Was the I is less than, while I is less than size of the array. Clearly the sentinel value must be chosen so that it cannot be confused with an acceptable input value. So I'll kind of give you the answer here. What you really want to do in the case of this grade program is you want to give the user the ability to input grades until there's no more grades to enter. You want to save those grades as either a string or an array. I would save it as an array. And as you saw in this for loop, I can, as a matter of fact, I can change this to int. Grades. I can change this to int. And then I can say I really don't want any of this stuff here. I can even say I don't care how many grades are in grades equals new grades. Huh? Does that work? Is that gonna make you go away? New grades. New grades. It's not gonna work. New grades. Give me 1 second. I want to look this up. This is gonna bother me. I know this is initialize or instantiate array. I want to instantiate empty array C. Here we go. Excuse me. What's funny is I think that in C you can only instantiate an array with a specific size. You can't instantiate an array without it. It has to be literal. So in this case, I wouldn't be able. But what you could do is this. So I'll show you a little trick. This is kind of cheeky, but you can do this. Instead of doing this array, what you can actually do is say string grades. And then every time someone adds a grade, so let's say I said printf and I asked them to give me the grades that they wanted, then I'd say, while input does not equal exit, I guess. Grades equals input. So that's kind of pseudocode. That's not necessarily how I would write it because I don't have an input yet. But essentially what it would be is a while loop. And the while loop would get all the grades from the user. And then after the user gave us all the grades, it would leave the while loop and then go into this for loop and then calculate all the grades. Or you can just, in this while loop, not even do this for loop, to be more specific now that I'm refactoring it in my head, and you can just add it. And you can say input, I don't know how to parse this string to integer, but it would be a string when you got it, so we'd have to parse it to integer. And then grades is already, I would say it's an integer, int. I would initialize that to 0. Heck, why don't we just build it? And then we can just whiz through the program, the example they have. So in this case, I have int grades equals 0, and I'm going to have a while loop that asks the user for all the grades that they want to enter, as long as input doesn't equal exit. So get input from user C. Yep, there we go. Come on, lady, be good. So printf is what gives us an output. If we want to input, we need to do scanf. So we'll say scanf, or actually printf first. Please enter each grade 1 by 1. Enter grade. I'll just say, please enter grade. Okay. And then what I'll do here is I will scan. So now I'll do scanf, and then I'll say interesting. What does the D stand for? I'm unsure. I see what it stands for. So D stands for integer. If I did that, it stands for integer. If I did an F, it stands for float, and LF stands for doubles. I don't really care about all that. I will take the integers, so D, and then I'll say and my keyboard doesn't have anything on it, so I'm pretty much typing blind. There we go. There is no input right now, so what I'm gonna say is, actually I don't need input. I can say I do need input actually. String input equals empty string, and then I'll say input here. That should resolve. It's not str, it's char. I keep making that mistake. There, that should resolve. It doesn't like empty string. Quoted string should contain at least one character. Fine, I guess. Is that good enough? There we go. All right, so empty string. And now, while input is less than or equal to exit, I'm sorry, is not exit. So it's that's not less than or equal to. I'm sorry, that is not. Grades is plus or equal to input. Now, what that actually means, and I'll write it in the comment section, is grades equals grades plus input. That's shorthand. This grades plus equals input is shorthand for this. And we just write shorthand because it makes it easier for us to write. It's less cumbersome and easier to read. Now, what you actually want to do in this case is you're asking the user for an input, right? And what you want to do, excuse me, I'm losing my train of thought. Actually, I don't want to do a while loop. I actually want to do a do loop. So, and I'll show you why in C. And we'll just go ahead and knock this out. There we go. So what a do loop is, it does something first, and then it satisfies a condition afterwards, or the Boolean condition. So in this case, what I want to do is I want to run this one time, because what that'll essentially do is it'll give me the information that I want, because it's always going to run once. It doesn't have to try to satisfy the condition automatically. It just needs to run one time. Now, if actually this might not work either, now that I think about it, unless, so I want to check to see if input is exit on this loop. So, and the reason why is if I try to add exit to grades and it's an integer, it's going to throw an error. So I need to check to see input is not equal to exit. Now this is how I would do it. I did not read ahead in the text. I don't know what they're going to tell you to do. This is just me coding off the top of my head. After that comes out of there, then we want a int average. Actually, we can say printf. We can say the class average is, and I'm sure that their class average and then plus average. Or actually, I can just do the calculation here and save myself a memory location. So it'll be grades. Oh, I also need the counter. I'm thinking out of it. Losing precious time here. Counter equals starts at 0, and when the first grade is entered, it'll do its magic. So if grade is not, we'll say counter plus plus. All right, and I'm gonna go over this after I'm finished, but right now grades divided by counter is our answer. Okay, I think I have it all taken care of. So let's run it and see if it works, and then I'll come back and tell you what I did. No, don't run it if it has errors. String D requires an argument of type int, but variadic argument 1 has a type char. Oh, you're right, because I actually want that to be a string. So how would I denote? S stands for string, eh? Yeah, it does. So we're gonna do S instead. Hey, that's gonna be a string. All right, run. No. Scanf, this function of variable, it may be unsafe. Consider using scanf s instead. Yeah, sure. Whatever you say, Visual Studio. All right. So, and you know, I'm, yeah, this is kind of really small, so I'm gonna make it bigger. There we go. So, and that's my dinner. I need to go put some more stuff in there, but please enter your grade. So I'm going to enter a grade, 100, and it threw an error. This access violation writing location thing is really getting old. Let's close Visual Studio. Let's just save that. All right, let's close Visual Studio, and let's reopen it and see if we can fix that, because that error is really getting bad. It's just not. It's really getting annoying, to be honest. So let's open up Visual Studio again. And let's try to run that. Where is it? I think it's this one, yeah? It might be that one, actually. Yes, it is. All right, let's try to run it now. Please don't throw an error. It's really getting old. Okay. Please enter your grade, 100. It doesn't like... All right, I'm gonna look this up really fast because it's gonna... Okay, but I don't have that star anymore. Why is it doing that? And a modifiable array on the stack. These errors, man. It's telling me, I know what the error is telling me. It can't write something into a specific memory location in the RAM. I get that. I'm just trying to find out access violation writing location, scan FS. Let's find out why it's doing this. I believe the error will go away if you make this change. Last name, count of last name, last name, count of last name. Huh? I honestly don't care about this exception. I'm going to be quite honest with you. Did it again, didn't it? Continue? Please? Alright. Maybe my computer is just, All right, let's test something. Let's say, instead of that, let's just say input. Maybe that's the problem. Yeah. Yeah, I get it. Let's stop. Run. Enter the grade. Unhandle exception doesn't like where I'm putting the code. Okay. Input. It's just something that I see, but it's not a char constant, so I'm sure that this isn't gonna work. This is already throwing an error. It's already yelling at me. Alright, give me 1 second. Alright, so we're back. I figured it out. I didn't want to waste too much time. First of all, I didn't convert my application to C. So when you use C++, or when you use Visual Studio, you need to make sure that you change your class to C. And you do that by renaming this to C. It was at first this, and now it's this. So that's good. So let's jump back into the context of the class, okay? So I believe we were somewhere around yes. So basically what we were trying to do is we were trying to create a function that reads the grades from the user and then calculates those grades as an average. Well, what I did, if I go back, is that I actually did just that. So I was able to create the program, and let's watch it run. So it runs somewhere. Oh, it's building right now. Give it a second. All right, so we have, please enter your grade, 100. Please enter the grade, 95, 82, 73, 64, 50, 99. And then I'm going to add -1. Now what -1 does is it's my sentinel to so that I can leave the do while loop. And there's my class average. The class average is 80. Now let's go ahead and test this out for a second. Calc. And then let's go ahead and put these numbers in and see what we get. So 100 plus 95 plus 82 plus 73 plus 64 plus 50 plus 99 divided by 1, 2, 3, 4, 5, 6. Is that 6? 7. 7 numbers. And would you look at that? It's 80. Now, why didn't it give me 80.42857 whatever? Because I'm not using a float to save my average. I'm using an integer. If I had changed it to float, which I actually can do right now. So if I changed if I changed grades to a float, float, and I believe that's the syntax for float. Before I go ahead and say that is a syntax for float, that was not correct. Well, actually, I can say float. And then I hope that's good enough, actually. Yes. %sign F is float. Okay, good to go. So let's run this now. All right. And let's add the numbers. So the numbers are 100. And I'm going to add different numbers because I don't remember the numbers that I used the last time. I just picked them out of the clear blue sky. But 100, 95, 82, 77, 73. I did not mean to do that. And I think the reason why that happened is because I added something that was not an integer. I added a dot. So let's go ahead and stop that and let's start again. C is very specific about data types. So you have to add the right data types. In integers and floats and doubles, it has to be numbers, not strings. So 100, we'll do 100, 78, 85, 82, 93, 89. And then we'll say -1. And look, I got a decimal. Floats will give you decimals. Now, if I did double, I think the decimal will be larger or smaller. I don't remember specifically, but in this case, it works. So let's talk about what I did. Well, I took float grades, integer counter, and int input, okay? And then I created what's called a do-while loop. Now, what's the difference between a do-while and a while? Well, as I said before, a while loop has the Boolean expression in the beginning. A do-while loop has the Boolean expression at the end. Now, what does that change? Well, in a while loop, if the expression's in the beginning, then it doesn't run what's inside of its body until after the Boolean expression or the Boolean condition has been satisfied. If this Boolean condition is true, and the Boolean condition is at the top of this, that was Thunder, by the way, then what will happen is this will not run. What it literally means is while this condition is not true, run the body. Now, what's the difference between the do? The do will run the body first, one time, and then it will ask, is this condition true? If it is not true, then it will run again until this sentinel value becomes true, this Boolean condition. So what's going on? So in this do loop, we have a print that says, please enter the grade. Then we have a scan function. We're just using scanf. It's built into C to scan for the input. And basically what I want is I want to grab the variable input, okay, as a integer. So D, integer, F, float, S, string, C, char. If the input is not equal to -1, which is our sentinel value, remember that's what causes this to not run anymore. If it's not equal to -1, then I want you to add the grade to input, and basically what this means is grades equals grades plus input. Print F, I want you to print the grade that was entered, and then use %d as the placeholder for input. Then I want you to increment the counter by 1. This basically means this. It's shorthand for counter equals counter plus 1. I use a lot of shorthand, and you should get used to it. It's something that makes your life a lot easier when you develop and whatnot. So shorthand is your friend. So counter plus plus equals this. As you can tell, if counter plus plus equals counter plus 1, what does counter minus minus equal? Counter minus minus equals, you guessed it, counter equals counter minus 1. And the same goes for counter times times and other ones. So in this case, we just need to increment the counter by 1. And then it'll check to see if input is equal to -1. -1 pretty much tells the program, do not run this loop anymore. Then we want to calculate the grades from the counter. So the counter tells us how many grades were entered, because the counter runs for the amount of times, it increments for the amount of times that the grades were entered. So it'll tell us the amount of grades that were entered. And I want grades, which is the sum total, to be calculated divided by counter. And then I want to save that back into the grades variable. So then it'll change into the average. And then I want to print that out. Return 0 just ensures that the program ran correctly. So you can add that to your program if you want. You don't have to. As I said before, it runs just fine. So if I try one more time and we just do easy, right? Easy numbers. So if it was 150, the average should be 75. So if I said -1 to stop the loop, I get 75. So it works. All right. So let's blaze through this since we've already written the program. So each refinement, as well as the top itself, is complete specification of the algorithm. Only the level of detail varies. So what this is speaking about is refining your code. So in the beginning, the code was not necessarily as refined as we would like it to be, because what we're trying to do is find a way to make it as efficient as possible. What you saw me do there in that program was making it as efficient as possible. So this is saying in the second refinement, we need a running total of the numbers, a count of the many variables, a running total of the numbers, a count of how many numbers have been processed, a variable to receive the value of each grade. And let me just skip forward so I can show you actually what they came to, because this is going to talk about a lot of the things that I've already spoken about. Oh, here's the pseudocode. So initialize total 0, initialize counter 0. In this case, I use grades. Input the first grade. While the user has not yet entered the Sentinel, add this grade to the running total, add 1 to the grade counter, input the next grade. If the counter is not equal to 0, set the average, and I didn't do that validation. So if the counter is equal to 0 and you try to divide the counter 0 divided by 0, you're going to get an error undefined. But I didn't do that validation. So this is one step that we didn't do that we can add later if that's necessary. If the counter is not equal to 0 or null, set the average to the total divided by the counter, print the average, else print no grades were entered. So let's go ahead and fix it, right? So let's say, well, let me show you what happens if this runs and there's no grades entered. So I have it right now. Remember, grades is equal to 0 and counter is equal to 0. If I don't put a grade here, grades equal grades divided by counter is going to be what? Undefined, because 0 divided by 0 is undefined. You can't divide anything by 0. So if I said -1, I'm going to get nan, negative nan, IND, which pretty much means not a number, undefined. I don't know what you're asking me to do. So let's not have that fire. So let's say if grades equals 0, and I don't know if that's the right syntax or not, because I've been writing in C# and PowerShell today, do something. If not, so else printf no grades were entered. Alright, so let's see if this works, which I will assume it does, but let's run that. Okay, I have my please enter a grade. If I hit -1 here, class average is nan because this if statement didn't work. So let's find out why it didn't work, and I'm gonna do a little research on my own. I probably just didn't put in a good syntax for this, but if statements, C, beam shell Zeme. I thought I did this last time, and what is the equals? Yeah, it's if grades equals 0. 0 is jeez, that's not right. All right, yeah, that was my fault. If grades is not equal to 0, then run that. Otherwise, okay, I had that backwards. My fault. So now if I put in -1, no grades were entered, class average is 0. And I can actually remove that from there and place that here because I don't want to see the class average if there were no grades entered. So now let's try it. And -1, and boom, no grades were entered. Looks like it ran just fine. So let's get back to the text. We finished the last part. Many programs can be divided logically into 3 phases: an initialization phase that initializes the program variables, a processing phase that inputs data values and adjusts program variables accordingly, and a termination phase that calculates and prints the final results. So let's talk about this for a second. We have the initialization phase, right? We are initializing our variables. We have the processing phase here. This processes our data. This gets our information. This is our business logic. And then we have the termination phase here, and I guess I could write that in there just so that the text has some girth to it. Initialization phase, init phase. We can say this is the business logic. This was the processing phase. And then the if statement at the bottom just checks to see if grades are equal to 0 or not. So this is our termination phase. That calculates and prints the final results. The pseudocode algorithm in figure 3.7 solves the more general class average problem. This algorithm was developed after only 2 levels of refinement. So sometimes you have to go back over and over again and refine your code because you'll see certain things that you can make better, or you see certain situations that you can refactor. We don't call it refinement, we call it refactoring. So I know this is calling it refinement, and that's fine, it's text. But in the real world, we call it refactoring. So let's get to the code. Here's the code. Let's see how close we are to what we wrote. They have an unsigned integer called counter. Okay, what unsigned does is C saves our files, or saves our values to any value that it deems open in the memory. If you create an unsigned int counter, what it actually does is it gives it its own specific memory location, so it doesn't override anything else. And if you see here, they also have a float average. I don't have a float average. I reused grade. I didn't want to use another variable. The more variables you use, the more memory locations or memory values you take up. So it's good to be cognizant about the memory locations that you're using. So initialization phase, it initialized total encounter. It then printed printf, and then it scanned. So give me 1 second. All right. So then we have scanf that gets the grade. And then while the grade is not equal to -1, we do this. Now remember what I said, total plus equals grade is the same thing as this. Counter plus plus is the same thing as this. Then what they do is they prompt again. We only prompt once because we use a do while. We didn't use a while. And that's very important. If the counter is not equal to 0, or if the grades is not equal to 0, then you can do this. So basically on our first factor, because I only wrote the code once, we were able to get the most efficient code that we could have written. And the longer you develop, the more you'll realize that it's easier to write code right or very efficient the first time than it is to go back and try to refactor it after the fact. So this is what they were able to get, and they have a float for a class average. They also have the no grades enter. So in the while loop, the braces are necessary. Without the braces, the last three statements, blah, blah, blah. So we spoke about this. What we did speak about also was infinite loops. And if -1 is not an input as the first grade, here, as you saw what happened when I did it, you'll get loops for days. And you don't want that. So converting between types explicitly and implicitly. So this is very important. If you want to convert between a string and an integer and a float, a string and a float, a character and a float, because there's no strings in C. I don't care what anybody says. It's just characters. What you'll need to do for the most part is you'll need to use specific methods to convert. So with that being said, you have to use what's called a unary cast operator to change the data type of a specific thing. So you saw that when I calculated the grades, it came back as an integer, and I didn't want it as an integer, so I went and specifically changed the data. Why isn't it changing? I specifically changed this data type to float, but I didn't have to do that. I could have, in this specific call, changed it to a float by changing this data type to a float through a data type conversion, like here. This is an inline conversion to float. So let's test that for a second, right? So let's say float. Please stop. There we go. Float. And then up here, instead of saying grade 0, I said int. Okay, let's run this and see what happens. So I have my call, 150. Now let's do -1. And look what I have. I have a float. Why do I have a float? Because I inline converted grades to float. I could have also converted this to a string as well in this line as well. So this is one way that I can convert between data types without actually changing the variable's data type. The grades variable data type is still integer. What this basically says is the output of grades needs to be a float. That's what this is basically saying. So C evaluates arithmetic expressions only in which the data types of the operands are identical. So if you try to convert letters to integers, okay, if you have your name, Francis, and you try to convert that to an integer, it's going to tell you that can't be done. So to ensure that operands are of the same type, the compiler performs an operation called implicit conversion. For example, in an expression containing the data types unsigned int and float, copies of unsigned int operands are made and converted to float. In our example, after a copy of counter is made and converted to float, the calculation is performed and the result of the floating point division is assigned to average. Meaning, the data type int or average still contains or is that type int. What we did was we said the output of average or the copy of average needs to be a float. So I'm just reading to see if any of this is completely necessary. It looks like it's not. Oh, okay. Formatting floating point numbers. So remember you saw I said decimal F. Well, if I wanted to define the amount of decimals I got back, so if I only wanted 2 decimals to be returned, I can say .2. So let's go back to our code and let's do just that. .2. 2, please. Thank you. And then let's do something that'll give us, well, actually, we can just do what we did last time. 50, then -1, And guess what? I only get 2 decimal places. I can say 3, it'll give me 3, 4, depending on how many decimal places that the float is supposed to give me. And that's called with precision. You're making your call more precise. If the %f conversion specifier is used without specifying the precision, the default precision is 6 decimal places. So just to show you that, let's go ahead and do this again. I don't mind showing you over and over again. 100, 50, and then -1, and you can count that 1, 2, 3, 4, 5, and 6 decimal places. So by default, if you do not add a dot and an integer there, like 2 or 3, it'll be 6 by default. When floating point values are printed with precision, the printed value is rounded to the indicated number of the decimal positions. The value in the memory is unaltered. Okay. When the following statements are executed, the values 3.45 and 3.4 are printed. But the value 3.446 does not change in the memory location. The only thing that changed is what you presented to the program. So, yeah, we can compare. Yeah, okay. All right, so let's work on another problem. We'll talk about a nested control statement. So consider the following problem statement. A college offers a course that prepares students for a state licensing exam for real estate brokers. Last year, 10 of the students who completed this course took the licensing examination. Naturally, the college wants to know how well its students did on the exam. You've been asked to write a program to summarize the results. You've been given a list of these 10 students. Next to each name, a 1 is written if the student passed the exam, and a 2 is written if the student failed. Your program should analyze the results of the exam as follows. Input each test result. Display the prompting message, enter result each time the program requests another test result. Count the number of test results of each type. Display a summary of the test results indicating the number of students who passed and the number who failed. If more than 8 students passed the exam, print the message, bonus to instructor. So, and this is basically a recanting of what we just said. So, let's proceed with top-down stepwise refinement. Let's not say we did. Let's just code it. So, we need to make this into a program which accepts 10 grades, and if 8 grades are 1 or 0, or if there's 8 grades that are, if the amount of the grades, I apologize, is 8, bonus to instructor. So first and foremost, let's just take this and make an else if, and we'll say grades, if grades is equal to, or I'm sorry, is greater than or equal to 8. There we go. Printf, bonus to instructor. All right. And then all we really need to do is we don't have to do an average anymore. So now all I'm going to do, I don't need a float. I can just use a integer. So I'm going to say D. The class there we go. The number of students who passed are. Now, with that being said, I am pretty much finished because everything that I have done so far, as a matter of fact, if not grades, but if counter equals 0, and I'll show you why in a second. So let's do this. Let's just test 1. Actually, I need to test if 10 students, not infinite. So let's not do that. Let's do this. I guess I can do a while, or I can just comment that out. For var I, not var, int I equals 0, while int is less than the size of, oh no, while int is less than 10, that's all I need, not int. What am I doing? While I is less than 10, I plus plus. And then I can say 4. What's wrong with you? There we go. So now I can put my code in there. Okay, this should work now. And I commented all this out, so it's going to ignore it. But all I really want to do is calculate 10 grades. So, actually, there are going to be build errors. Why? An uninitialized input was used. Uninitialized input. Right. I need this. All right. There we go. All right, we're good. Now, let's go. One. That is very annoying. So I'm gonna get rid of that, or we're gonna comment that out because I don't want to see every grade that I enter. Okay, let's try that again. All right, we're in there like swimwear. 1. The number of students who passed are 10. Now, it didn't tell me. If not equal to 0, and let me fix this. I don't have any key things on my keyboard. There we go. And grades are less than 8. And I'll explain to you what I'm doing right now. Right now, I just want it to work. So we got the first part working. That's good. Here we go. 1. Bonus to instructor. It worked. So let's talk about what happened. Well, we have the same business log. We have the same initialization phase, grades, counter, and input. We didn't really have to change any of that. All we really need to do was change 2 things. 1, we wanted to change the fact that we didn't need a average. That was not important. All that was important is that we calculated how many people passed and how many people failed, and then display bonus to instructor if more than 8. If 8 or more individuals passed. So let's go over the syntax. So I use the for loop because it's the fastest. Literally the fastest loop you can ever use. So for integer I equals 0, so we initialize I to 0. While I is less than 10, that means that when I equals 10, it'll stop running. Increment I by 1 every time we iterate. So printf, please print this grade, please enter this grade as you saw. And then scanf takes the grade input, or takes the grade that I enter and gives it to the variable input as an assignment. Then what I'm asking it to do is add input to grades, and then I want to increment the counter by 1. Now I don't need this counter anymore because I'm using in for loop, so I can actually get rid of that. The reason why I don't need the counter anymore is because I is my counter. Or actually I do need the counter now that I think about it, because I want to check if the counter is equal to 0 or not. If the counter is equal to 0, then I want it to say no grades entered. So let's check to see if that works. So right now, if the counter is not equal to 0, and, this means and, so I can add 2 Boolean expressions together, Boolean conditions. I can also use or, which is 2 pipes. So if I said or, I can also use that as well. But in this case, I want them both to be true. So this means if this is true and that is true, run what's in the middle, or run what's in the body. So in this case, if counter is not equal to 0 and grades is less than 8, I want you to display the grades. As a matter of fact, I want you to display the grades in this one as well. Okay. If grades is greater than or equal to 8, bonus to instructor number of students that passed. Else, and that's catching everything else. Basically, it runs whether or not there's a condition there. No grades were entered. So, -1 did not work. Right. Right. I have a solution for that. So, you can use a while loop and use a sentinel, or I can say if input, oh man, that's not input. Input equals -1. Actually, I should put this in the front. If input is equal to -1, then I want to leave the for loop. So what break means is break out of whatever loop, whatever thing we're doing, get out of it. Stop, don't do any more, just get out. So break, I can also say return 0. This should work though. So let's try it. Stop, run, build errors. Where's the build error? Input not used. You are having a giggle, mate. The input is used. Oh, there's something assigned to it. Okay, I'm gonna assign a 0 to it then. There you go. Let's try it now. If you initialize a variable and there's nothing assigned to it, like if you put the assignments inside of a do loop or inside a for loop or if loop, it's not going to work. If statement is not going to work because it's not really been assigned anything. You have to assign it a value for it to actually matter to the program. So in this case, I'm going to write -1. The students who passed are -1. That is not okay. And the reason why that happened is because the counter ran. I don't want the counter to run if it breaks. So what do I do? What do I do? It was just supposed to break there and never write anything else, but it ran the counter, which means that counter was now equal to more than 0. But if it's equal to 0, this won't run. So I don't want to use a while loop, but you could, in this case, use a while loop, but I don't want to. I actually just want to break. I mean, I could change it. I just don't want to. I'm being stubborn. Fine. Well, that's how a for loop works. So I'll put it into a while loop to fix the problem. So while counter is not equal to 10, or while counter is less than 10, let's do that. While counter is less than 10, I want you to run this, right? So what's going to happen is, or input. Wait a minute. I'm going to have to do a do while because I need to get the input first. Well, that stinks. That stinks. I wanted to use another loop, but it'll be too much development, so I'm just going to go ahead and use the do while because it seems like it's the best solution. Well. So if input's equal to negative, okay, and we want to add one more validation. If counter is less than 10. Or. So what does this mean? If while counter is less than 10, or input is not equal to -1. What does that mean? That means if any one of these are true, this is true. If it was an and here, what that means is if both of them are true, this is true. So this can be true and that can be false in an or, and this will be true. The whole thing will be true. So let's test it. All right. I also don't need input to grade. Well, maybe I do. Input counter. All right, let's just run it. Oh, disappointing. I didn't want to use a do while again. I wanted to use something else, but it's okay. So 100 -1, and it still didn't work. It should have ran. Input is not equal to -1. But it went again. Oh, I think I know the problem. It also depends on the where you put those. So let's try that one more time, shall we? And if this doesn't work, I'm just gonna give up. The for loop worked. It did. That's annoying. That tells me that I can't put a Boolean expression like this in here. That's disappointing. Very, very, very disappointing. What if I said, hold the phone. What if I said, if else, it was easy. There we go. Now let's try it. Never give up. Never surrender. Oh! There it is! Too easy. Alright, so the breakpoints here in the else loop. What did I do? I'm using the do loop again, so we went over that earlier. If you don't remember, just rewind video. But what I said here was, if -1, because I can't put that in the Sentinel. I couldn't put break the loop if input is -1. I need to only break the loop if the counter is less than 10 or is greater than 10. So I still wanted to break the loop if the input is not equal to or is equal to -1. So what I said was else break. That means that if the input is -1, break the loop. And guess what? That's what it did. That's what I was trying to do in the for loop, but it was not playing nice. Okay. So let's see what they did. Yes. If I see anything that I need to explain, I will. So here's the kind of pseudocode. Give me a sec to H2O. Initialize passes to 0, initialize failures to 0, and I'm not printing the passes and failures, but you can if you want to. It's not, I mean, to me, it is what it is. But you can add 1 to failures and add 1 to passes. I mean, I guess that makes a lot of sense. While the student counter is less than or equal to 10, which is what I did, by the way, input the next exam result. Now, once again, it doesn't have validation for whether or not I didn't add any grades. So, issues, yeah? They're going to refactor it, though. And here it goes. So, int student equals 1, blah, blah, blah. We didn't do this. While student is less than or equal to 10, enter result, 1 pass or fail, add the result. If result is equal to 1, add 1 to pass. Elsewise, add 1 to failure. Student equals more than 1. Increment 1. If passes is greater than 8, puts bonus to instructor. And bada bing, bada boom, I don't see bonus to instructor because it says passed 6. So it looks like the instructor really didn't do his job. But either way, no, that's not true. That just means that it was some students had a harder time passing the class than others, so. And there is bonus to instructor, 9 passed, 1 failed. So, this is what I was talking about. C equals C plus 3. You can just say C plus equals 3. This is the same thing. This is shorthand. It's called the addition assignment. You have multiplication assignment, subtraction assignment, division assignment. I don't know if modulus has assignment. I've never tried it, though. So, and here modulus does, I think. No, it doesn't. So in this case, we're speaking about assignment operators. So in this case, you have binary operators for plus, minus, multiplication, division, and or modulus. Modulus, all that means is remainder of, taking you back to 3rd grade. So 10 divided by 3 is 3 remainder 1. That's it. So the modulus for 10 divided by 3 is 1. So 10 divided by 3, if I did 10 modulus 3, I would get 1. Because 10 divided by 3, if I was doing 3rd grade math, is 3 remainder 1. There are times where you want to know the modulus. I know that sounds wild, but there are times where you want to know the modulus. And here we go. These are all the... they do have modulus equals. So, yes, they do have all these shorthand assignment operations that you can use, which are... very nice, indeed. Very nice. So, C plus 1 C plus equals 1 is basically, if you want to increment by 1, you can use the variable or the number plus plus. If you want to subtract by 1, you do the variable or number minus minus. This is called an increment operator and a decrement operator, and you've already seen me use them because it just makes a lot of sense, right? So, counter plus plus, grades plus equals endpoint. I just do it off the top of my head. I don't even go and look at it. I know what I want. I put it in there. That's shorthand. There's also ternary operations once you get into JavaScript and things like that. That'll show you how to write if statements in shorthand. I know it looks like gibberish and really cool if you're trying to impress people, but most real-world senior-level developers develop like this. This is just the way we do it. It just makes a lot more sense that way. Alrighty then. You can also pre-increment and post-decrement your code, your variables. What does that mean? That means you put the plus plus before the variable. I never do that, but you can. So pre-incrementing or pre-decrementing a variable causes the variable to be incremented by 1. Then the new value of the variable is used in the expression in which it appears. So what that means is if you have a expression that uses that variable, and you say plus plus 8, 8's not the number it's going to use. It's going to use 9 because you're telling it increment this variable or number before the expression is run. I never do that. If I'm going to use 9, I just use 9. You can though, if you want. And that's a pre-decrement or pre-increment, post-increment, pre-decrement, post-decrement. Ho, say that 5 times fast. All right. And this demonstrates how you can use it in the printf and things like that. So I have C5 is initialized to C. So we're going to print C. So prints 5. Then we're going to prints 5. Then what that line actually does here, okay, is it prints the variable 5 and then it adds 1 to C. Okay? And then in the next line, C is now 6. In this case, in the next one, C equals 5. So if I print C, it's 5. But what I'm saying is increment the C, increment whatever's in C before you run the expression. So then it runs the expression printf, and the number is now print 6 instead of 5. That's the difference. If that's confusing, rewind it, listen to it again. It can be very confusing. Just know that variable or number plus plus is a post increment. Increments after the expression is run, which is actually what you want in most situations. The program displays the value of C before and after the plus plus operator is used. And I'm not going to confuse you guys anymore. All right, 3 assignment statements are here. Passes, we'll just see that these are all written in longhand when they could be written in shorthand. And the same goes for these, because if you have 1, I mean, that's just increment, right? I'm incrementing passes by 1, so I can just say passes plus plus. Done. It's important to note here that when incrementing or decrementing a variable in a statement by itself, the pre-increment and post-increment forms have the same effect. They increment the variable or number by 1. They both do the same thing, just at different points in the code. It's only when a variable appears in the context of a larger expression that pre-incrementing and post-incrementing have different effects. And in most situations, you're going to write them in the context of shorter expressions, so you don't have to worry about that. But if you do write them in the context of larger expressions, post-incrementing is exactly what you want to do in most situations. Or just don't increment at all in larger expressions at all. Just don't do it. So, the operators are shown. Wow, Hungarian Rhapsody, or was that something else? Either way, the second column indicates the associativity of the operators at each level of precedence. Notice the conditional operator. Ternary operation. That's what that is. That's a ternary operator, and I'll show you what it looks like. So, if I come in here, you see this if statement? Let's find an easier one, actually. This one's too much of a branch. That is too much of a branch. You know what? I could put it here. Let's say char output equals input equals -1. Oh, this is going to look real good. No grades. Some grades. This is called the ternary operator. I know it calls it a conditional expression or an operator, but it's a ternary operator. What is it doing? So I have the character variable output, and actually I'm gonna printf out of these. As a matter of fact, I don't even have to say this to a variable if I don't want, so I'm not going to. So, what is this doing? This is asking a question. If input equals -1, this question mark means then print no grades. This is your truthy statement. Otherwise, which is what this semicolon means, and this is your falsy statement, print some grades, which I didn't say printf. Let's see if it works. Throw an error. It didn't. Wow, on the first try. -1, no grades. It printed. I mean, granted, I could have put a thingamabobber there. And try that again. Sometimes it doesn't pop up. I don't know why. No grades. This is a conditional expression or a ternary operator in JavaScript. What this actually does is it does an if statement, but on one line. Now, here's the problem with this. It can't just do an if statement. Now, I misspoke. With conditional expressions, you have to do if else. If you do not define the else, it'll throw an error. So, let's say I didn't do the else. Let's just say I didn't write anything there. And I ran it. I'm going to get an error. Expected, it expects the colon. So let's say I put the colon there, and I didn't do anything else. And I ran it. Error. Quoted string should contain at least one character. It's just not going to work unless I put something there. This means empty string. What if I said null? Is that going to work? Absolutely not. Null is undefined. I have to put something there for the else. So in a conditional expression or ternary operator, if or true and false statements must be defined. Alrighty then. That being said, let's jump back in because I think we're almost to the end. And here we go. Take a quick look at it. This is slide. Oh, I gotta move myself, 139. And I'm back. So, sum equals integer 1 plus integer is an arithmetic overflow. Even this simple statement has a potential problem. Adding the integers could result in a value that's too large to store in an int variable. This is known as arithmetic overflow. This happens in C a lot because C works at the processor level, which means you have to be cognizant of your memory value buffer overflow. You can't just throw things willy-nilly in there because you're going to get a lot of issues. So, you need to define and understand the maximum and minimum values which can be stored in an int variable, which is represented by the int max and the int min, which is also defined in the limits header, which I don't think I have. I do not have. That's very annoying. So, in general, here we go. You can see your platform's values for these constants by opening the limits header. I'm not going to do that. And you can pretty much go into detail about what you can and can't use in your code. An unsigned integer. Variables of unsigned types can represent values from 0 to approximately twice the positive range of the corresponding signed integer types, meaning that you can use larger integers if they are unsigned than if they're signed. But we're not going to do that. The class average, well, you will probably have to do that. I'm not going to do that. So, the class average program could have declared an unsigned int the variables grade, total, and average. Grades are normally values from 0 to 100, so the total and average should be greater than or equal to 0. We declared those variables as ints because we can't control what the user actually enters. The user could enter negative values, and for unsigned integers, that's not necessarily allowed. Worse yet, the user could enter a value that's not even a number. We didn't validate for that, but that's actually very important. If I added something that other than a number to that program, I'll get a very gnarly error, and it might even do an infinite feedback loop. So, and sometimes Sentinel controlled loops use invalid values to terminate a loop. For example, the class average program terminates the loop when the user enters the Sentinel -1, so it would be improper to declare the variable grade as an unsigned int because -1 would not work. As you'll see, the end of file indicator, which is introduced in the next chapter, is often used to terminate Sentinel controlled loops, is also a negative number. And the reason why is because negative numbers aren't numbers that we're going to use. You can't get a negative number on a test. That's literally impossible. If you do, then there's something wrong either with the test or you just did really bad. Which I know you guys don't do bad on your tests. You guys are awesome. So, you know. Scanfs is the safe way to scan something. And Visual Studio will throw all kinds of gnarly errors if you don't use it. So, for instance, let me go back one. Visual Studio. And let's erase this S, shall we? Load it. What's the error? Scanf, this function or variable may be unsafe. Your punishments shall be more severe. Because I already knew that. So, the program's telling me if you keep doing this, I'm not going to work with you anymore. So, what I need to do is I need to put it back. Now, what does that do? Not a whole lot. It pretty much safeguards the program against buffer overflow. That's why it's there. That's all you really need to know. So, you know, prior to publication of the C11 standard, you could use scanf. Just don't. Not in Visual Studio. In other IDEs for like Raspberry Pi, sure. All you want. It's not really going to mind. But with the context of Visual Studio, it's been deprecated. And like you saw there, it was heavily deprecated and things will not run. So. Yeah, and we've already got that. I showed you the error, so we're going to have to go through this. But with that being said, I can't scroll anymore, which means we're done. So, if this has been fun and you enjoyed it, great. Keep watching for the next chapter.
Otherwise, if you have any questions or concerns, reach out to me and let me know. It's been fun, and I would like to say, ciao.